Day 18 of 75, and this is the one that flips a switch in your brain. Here's a problem. You've got a conveyor belt of packages, each with a weight, and you must ship them all within D days in the order they arrive. Find the minimum ship capacity that gets the job done. Your first instinct? Loop through every possible capacity and check each one. On large input, that for loop times out instantly. But there's a trick. The answer itself is sorted. And anything sorted, we can binary search. Stick around, because this single pattern unlocks a whole class of interview problems brute force can't touch. Let's see why the answer space is sorted. Imagine capacity is tiny, like 1. Each package needs its own day, so you blow way past D. Now crank capacity up to the sum of all weights. Everything ships in a single day. See the monotonic property? Small capacity means too many days. Large capacity means few days. And somewhere there's a crossover point where you first become feasible. That crossover is your answer. We're not searching the array anymore. We're searching the range of possible capacities, asking one yes or no question. Can I ship within D days at this capacity? Here's the feasibility check in Java. We write Boolean can ship, int, weights, int days, long capacity. Walk the weights with a running load accumulator. When adding the next weight would exceed capacity, you reset load and burn a day. Like this. Long load equals 0, int needed equals 1. Then for each weight, if load plus W capacity, needed plus plus, load equals W, else load plus equals W. At the end, return needed equals days. Notice it's a pure method, no search logic inside. That means you can unit test it on its own, which is exactly the discipline interviewers love to see. Now the bisect loop. Set your boundaries with intention. The lower bound is max, weights, because capacity must hold the single heaviest package or it never fits. The upper bound is sum, weights, the one-day case. Pin both to long so summing a big array never overflows. Then, while low-high, long-mid equals low-plus, high-low, /2. If can ship, weights, days, mid. High equals mid, else low equals mid plus 1, and return low. That midpoint formula avoids integer overflow. And watch the boundary discipline. Low-high, not low equals high. When feasible, we keep mid as a candidate with high equals mid. When infeasible, we discard it with low equals mid plus 1. That asymmetry is what makes it converge instead of looping forever. Why does this terminate? Every iteration shrinks the range. And because feasibility is monotonic, once you're feasible, you stay feasible going up. The loop collapses low and high onto the smallest capacity that still passes. Complexity? You're doing log of S iterations, where S is the sum, and each can ship is O of n. So O of n log S total. Compare that to brute force scanning every capacity, which is O of n times S. On a 10,000 element array, that's the difference between instant and timeout. Now the payoff. This template is reusable. Take Coco eating bananas. Coco picks an eating speed, and you want the minimum speed to finish all piles within H hours. Same shape. Lower bound is 1, upper bound is the largest pile. The feasibility check counts hours. For each pile, hours plus equals, pile plus mid, 1/mid. That's the ceiling division done in pure integer arithmetic, no doubles, no precision bugs. Then ask hours equals H. Drop that into the exact same bisect loop, and you're done. Split array largest sum, painter's partition, minimum speed to arrive on time. All the same skeleton with a different feasibility predicate. A clean way to package this in Java. Write a generic long solve, long low, long high, long predicate feasible, method holding the bisect loop, and pass your feasibility check as a lambda. The long predicate becomes a tidy API boundary. Search logic lives in one place. Your problem-specific yes or no question lives in another. That separation is the whole lesson. Here's your decision checklist. 1. Are you minimizing or maximizing a single numeric value? 2. Can you check feasibility in O of n? 3. Is feasibility monotonic, false then true? 3. Yes means binary search on answers. Day 18 done. The takeaway. When you can't search the array, search the answer. Subscribe for day 19.